In the rest of this unit, we're going to discuss text files and how you set them up and produce them. We're going to begin with something called the file class. The name might imply that this is actually something that opens and closes and uses files, but that's not quite right. It's more for file maintenance in terms of determining whether or not a file exists and what directory it's going to be in and what its file name is going to be and so on. The file name that we actually use is a string, and the file class is effectively a wrapper class for the file name and the directory path associated with it. So the file class then contains all the appropriate methods for determining the properties of a file and or directory, and also for renaming and deleting files and directories. So in other words, it's like for file maintenance. Here we see a UML diagram for the file object. This file object does not give us the ability to actually open and close files and read to them and write from them, but rather it's just used for obtaining file properties and manipulating the file. So we will need to use it, but we will need some additional objects to use to actually open a file and write to it and read from it. So the way we'll use it is normally with the constructor you see up at the very top, where we will give a file name and possibly a path name associated with that file name. The file object is designed to be platform independent, and we have two screenshots in this slide showing what happens when we use this file object in the context of Windows as compared to in the context of a Unix or Linux system. And you can see that the output is very similar. It's not exactly the same, but at least we can use all the same methods and get similar results from them. On this slide, you see the source code that generated the output in the two screenshots on the previous slide. The name of this class is testFile class, and in the main method what we do is we first of all use the file class that we discussed earlier and we saw the UML diagram for, and we create an object called file of that class. Once again, we can't do things like open and close the file and read and write it and so on, but we can do some rudimentary file management things with it, and that's what is shown in the rest of the source code that you see here. So we pass it an argument representing, as I mentioned earlier, possible path name and file name. In this case, we have a partial path name, not a complete path name. So it's from actually the bin directory, I think, is where this would start. And it's subordinate to that a folder called image, and then under that an actual file called us.gif. Now, we don't actually know at this point that us.gif is a file. You'll recognize the extension, I'm sure, as a graphical image, and you'll know that it should be a file, but there would be nothing that prevents us from creating a folder that happens to have that name, even including the extension. So for all we know, we could be looking at a folder called image and subordinate to that another folder called us.gif. We'll find out that that's not the case. We can tell by some of the system out print lines that appear below, but we'll talk about that when we get to it. So let's now go through those lines and see what happens. The first thing we do is we print does it exist, and then to that string we concatenate the result of file.exists. Remember, that returns a boolean indicating whether or not the file mentioned actually does exist. At this point it could still be a directory. We don't know that just yet, but that will come in a couple of lines. In any case, we are going to get a true printed for this if we do actually have that file on our system, and presumably we will. In fact, in the screenshots that you saw earlier, it definitely was there. Continuing on, the next print line prints the file has, and then a number, and then bytes. So many bytes. And the number that prints is the returned result from calling the method length on our file object. And that, of course, tells how big the file is. The next thing we do is we query the canRead method. So we say, can it be read? And to that string we concatenate file.canRead. And we will get true because it is readable. It's also writable, so when we ask can it be written and we print file.canWrite, we're going to get a true out of that as well. Now here's the one you've probably been waiting for. Is it a directory? Because it could be. It turns out it's not. But what will happen then is to that we concatenate file.isDirectory, And finally, we're going to get a false for that one because it's not a directory. It should actually be a file. But if it was a directory that happened to have that name, then that would return true. In the next line, we say, is it a file? It turns out it's not a directory, so is it a file? That's the next question. And that will return true because it is a file. The next query is it absolute? And to that we concatenate file.isAbsolute. Is it absolute? We'll print false. Is it hidden? We'll print false. And then the absolute path and the last modified. You can look back on the screen dumps to see what those things printed out.